Welcome, geometry class. I know you're so excited to be able to watch this awesome lesson, but I'm sure half of you think you're smarter than a fifth grader, so you're probably not watching my videos. You're probably just taking notes by yourself. Amy and Ethan. Just kidding. All right. So, of course, you know, I'm not about to write all these definitions and theorems. I'm going to do shorthand, so you're going to have to do the rest on your own. If you cannot see, I think you can see that. It kind of looks clear. Oh, doesn't it? Okay, oh well. Read it on your paper. First theorem. So they all start within the same circle or in congruent circles. Ooh, excuse me. I got the hiccups. First one says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords, and I'm kind of writing sideways because I have to reach around the tripod, so sorry, are congruent. So that says if two minor arcs are congruent, in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if we look at the hypothesis, we have the circle with the two chords, and if it was given that arc FG, oh, I wish I had my highlighters. Oh, I have one of my kids' color pencils. Arc FG is congruent to arc AG. Then our conclusion that we can make for that one would be that chord FG is congruent to chord HJ. Got it? And then here it says if chord FG is congruent to chord FJ, then our conclusion could be that arc FG is congruent to arc HJ. So if and only if, remember, that means you can read the same thing backwards and forwards. Everybody got that? I kind of feel like maybe I should. Oh, then you can't see it. If you can't see it, sorry. Just kind of listen. But hopefully it does. You can't see it when it's magnified on your phones or whatever. So, got it? Okay. The next theorem says that if a diameter that's if a diameter or a radius of a circle, if a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. So if a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. Got it? So if you look at the picture, we have the diameter AB, or you can say radius CB, however you choose to look at it. It's perpendicular to chord XY. Everybody see that? So since it's perpendicular to chord XY, then our conclusion could be that chord XZ is congruent to chord ZY. Make those two congruent. And arc XB is congruent to arc BY. Got it? So if it's perpendicular, the diameter radius is perpendicular to a chord, then that means that those chords that are bisected and the arcs are congruent. Got it? Okay, so let's look at the next one. I'll scoot it down a little bit. This one says the perpendicular bisector. The perpendicular bisector of a chord is a diameter. The perpendicular bisector of a chord is a diameter or radius of the circle. Or radius of the circle. Got it? So the perpendicular bisector of a chord is a diameter or radius of a circle. So here when we look at the picture, you see AB, and this is B right here on the outside. The diameter is a perpendicular bisector of the chord XY. How do we know it's a perpendicular bisector? Glad you said that. Because we see our tick marks right there. That shows that it's bisecting and cutting into two congruent parts. So since the diameter is a perpendicular bisector of the circle, then we can conclude that AB is a diameter of circle C. Got it? So the perpendicular bisector of a chord is a diameter. Okay, so now it's time to look at some examples. Yay! Read this in your head or aloud. Oh, you can't read it aloud. Never mind, because you're listening to your own devices. But I know one of you smart little kids are reading it aloud just to be you. It says, I'm tired. Let me sit down. In the embroidery hoop, chord AB is congruent to chord CD. And we see that on the picture. If you can't see, it has tick marks. And the measure of angle B is already labeled and it's equal to 60 degrees. Find arc CD. So based off the theorem, we know that if the two chords are congruent, that means what? The arcs are congruent. So arc AB is congruent to arc CD. So since AB is 60, that means this one is also 60 degrees. Yes, you're so smart. All right, let's look at the next one. That was a waste of space. I think I might zoom in on the picture on this one. Why is it so blurry? Oh well, look at your own picture. Sorry. I tried to help. This is an HD camera. This is just Nolan Ryan. All right. So it says in the figure, circle J is congruent to circle K. And arc MN is congruent to arc PQ. We see that with the tick marks right here. I'll make them a little bit bolder in case you want to see it. And it wants us to find PQ. So we're finding the actual chords. We know that if the arcs are congruent, then the what? You said it. The chords are also congruent. So if we look at the chords, they're given measurements. And so basically we're going to do what with those two? Yes, you're right. Set them equal to each other. So we have 2x plus 1 is equal to 3x minus 7. Subtract 2x on both sides. We're left with 1 equals x minus 7. Add 7 to both sides. And x equals 7. And that's our answer. I am glad you said no. Thank you. We have to ATQA answer the question asked. The question asked us for PQ, so we plug it back into PQ, which is 3x minus 7. So we do 3 times 7 minus 7, and 21 minus 7 is what? I did something wrong. Oh, I'm sure y'all been shouting it out. Yeah, I'm sorry. This is 7 plus 1. That's supposed to be 8 over here. My bad. Look, I'm focused on getting out of here, not the work. Just kidding. That's supposed to be 8. Sorry. I'm sure some of y'all caught it. You changed it. Good job. People make mistakes. I'm not just human. 24 minus 7, the answer is, yes, you're right, 17. Everybody got it? Questions? All right, if you have a question, too bad I'm not there. Ask Miss Thomas. All right. Example. Oh, not 4. I'm sorry. Scoot it up a little bit better. 3. There we go. All right. Example 3 says in circle S, arc PQR is equal to 90 degrees, 98. So that whole arc right there is equal to 98. And it wants us to find, where's my little thing? Arc PQ. There we go. So that entire arc is 98 and the smaller one's PQ. If you remember the theorem, it said if you had a diameter or radius that's perpendicular to a chord. So if you look here, SQ is our radius and it's perpendicular to chord PR. So then the theorem tells us that it does what to each other? Yes, you said it right. We know that it bisects. And so, hold on, I'm doing something. I'm doing math in my head. Okay, so we know PQ is going to be congruent to PR. But I just lost my train of thought. Okay, sorry. Sorry, guys. I'm taping this. It's midnight. I'm tired. I lost my train of thought because I was looking at the 6s and I didn't realize 98. Okay, yeah. So we know that the 2 are congruent, right? The 2 arcs. So basically all we're doing is just taking 98 and taking half of that. And so 98 divided by 2 is 49. Is that all it wanted? Man, that's all they wanted. Okay. Any questions? All right, good. Moving along. There we go. Example 4 says, in the stained glass window, hopefully you can see the window clear on your paper, the diameter is GH. I'll kind of make that a little bit bolder here. There's our diameter, GH. And it's equal to 30. And then we have chord KM. It's right there. And that's 22, so that one's 22. The diameter is 30. It wants us to find JL. For those you can't see, JL is right here. Everybody got that? So if we look at it, we know the full diameter is worth 30. And we know the chord. That means that if we were to kind of split it, that this entire thing right here, JH, would be half of 30, which is 15, because that's a radius, right? And we also know that the radiuses are congruent anywhere from the circle. So if we were to connect from J to anywhere on the circle, that radius would be also what? 15. If you wanted to connect it this way, you could. And that would also be 15. Because remember, all radii are congruent because they're coming from the central angle, right? So that could be 15 or that could be 15. And what is it creating? Because remember, it's perpendicular. So it's going to create a what? Good job. Hope you said it. It's creating a right triangle. Here it wants us to find JL. What else am I missing? What do we know? Okay, we know the whole chord is 22, so we know half is going to be 11 and 11. Can y'all see that on your paper? Ooh, you really can't. There we go. I guess that kind of helps a little better. So far I have labeled our radii 15. It's perpendicular, so I connected those and we have a triangle. And the whole thing was 22, so we split it into 11 and 11. And so how can we find out what JL is? Hopefully you said it. Yes, you're right. It's the Pythagorean theorem. So we have our hypotenuse, which is 15 squared. And that's equal to 11 squared plus we don't know JL squared. So 11 squared plus JL squared is equal to 15 squared. We know this is 225. 11 times 11 is 121 plus JL squared. Subtract 121 on both sides. I didn't bring a calculator home. So I kind of got to do this in my head. So that's 4, 0, 2 minus 1 is 1. Hope it's 104. If not, I'm sure you'll let me know. Take the square root of both sides. And so JL is the square root of 104. And it didn't tell us how much to round it by. So you can just say JL is the square root of 104. Or, oh, I can use my phone. Or you can put it in your calculator and come on, square root of 104. Oh, there we go. Is equal to 10 point, we'll say 2. Got it? Good job. All right, I'm gonna zoom out now so I can move to the next theorem. Man, this is a long lesson. Oh no, I only have 4 minutes left on my clock. The camera cuts off at 20 minutes. Okay, gotta go fast. All right, the next theorem. So in a circle or congruent circles, remember most of our theorems start with that. Two chords are congruent if and only if they are equidistant. Sorry for the messy handwriting. I'm writing in between a tripod from, and my handwriting's messy anyway, so who cares, from the center. So two chords are congruent if and only if they are equidistant from the center. So if we look at the picture that we have right here, we see F, if it was given that FG, chord FG was congruent to chord JH, if and only if LX was equal to LY. Now we see LX and LY, they're equidistant from the center. Everybody see that? Uh-oh, you can't see it because it's off the screen. There we go. So,
sorry, I'm not sure what you said.
Oh, sorry Siri, I'm trying to teach. In circle A, WX is congruent to XY. Where's WX? Oh, that chord right there is congruent to this chord right here, XY, and it says they're both equal to 22. Does everybody see that? It also tells us to find AB. So if we look, if those two chords are congruent, then we know from AB to what? AC, you're right. Those are also going to be congruent. So this is just simply setting 5x equal to 3x plus 4. Everybody got that? Subtract 3x on both sides. 2x is equal to 4. Divide by 2. X equals 2. The question asks us to find AB. Where's AB? AB is equal to 5x. So we do 5 times 2 and we get 10. Got it? So just remembering that it's equidistant. So since those were equal and they both equal 22, then those were also equal. Any questions? I hope you enjoyed this lesson. Thank you.